This is part 3 of the lecture on chapter 12, Assembly and Packaging. So please turn to page 256, where we are going to start talking about quality assurance measures and using internal chemical indicators. So in order to get something sterile, we have to go through many steps. One of the steps we have to do is we have to provide some sort of evidence that sterilization took place. So there's no proof of sterility. It doesn't matter what type of indicator you're using, biological, chemical, the physical monitor that prints off of the machine. None of these are actually proof that sterilization took place. What they are is they're pieces of evidence. So assuming that all of the necessary things were done, that the instruments were cleaned properly, were assembled in a fashion that allows the sterilant to get in and penetrate and contact all the surfaces, there was no water, no moisture in the set, and the sterilizer was loaded properly. So there's a lot that goes into it. So we have, we need some kind of evidence that the sterilization took place, in addition to making sure that we do everything right. So, talking about chemical indicators. A chemical indicator is a little strip of paper with a chemical printed on it, or some similar device that will change to indicate that the sterilant was present. So if you look at page 257, there's a variety of chemical indicators in this picture here. Some of these are for steam, some are for a other process like ethylene oxide. It's a pretty small picture and it's not relevant. It just shows that there's a wide variety of types. The two biggest chemical indicators in use for steam are type 5 and type 6. Now, your book says class 5, but the language has changed. We now refer to them as type 5 and type 6. So a type 5 integrating indicator. It integrates 3 parameters that are necessary for sterilization. The presence of the sterilant at the elevated temperatures and pressures, and then time. So those are 3 things that we need for sterilization to take place. The sterilant at the correct temperature and pressure and time. So a type 5 indicator will monitor all 3 of these parameters, whereas the previous versions of indicators like the type 4 would indicate the presence of the steam and the elevated temperatures and pressures, but it would not account for time. So this is why a type 5 indicator was a nice advancement over that. But because there are other cycles that are not your standard 4-minute cycle, we may need a type 6 indicator, which goes outside of the normal standard parameters. So look in your book on that bullet point where it starts talking about type 6 or class 6 emulating indicators. They're verification indicators or cycle-specific indicators. So let's say that you have a complex instrument set that requires something beyond 4 minutes at 270. So let's say 8 minutes at 270 degrees. Now a standard type 5 integrating indicator will indicate that 4 minutes happened. So it will show that the sterilant was inside of the container for 4 minutes at the elevated temperatures and pressures, but it will not indicate that it was in there for 8 minutes. So if you have something that requires an extended cycle, you will probably want to use a type 5 emulating indicator. They make them for a variety of different cycles and temperatures. But still, for now, the type 5s are still very common. They're the kinds that are going to be inside of a process challenge device. A process challenge device, as explained on page 258, is some sort of a challenge to the sterilizer. So the ones that you're probably going to see most commonly are the ones that are produced by the 3M company, and I'll show you what's inside of those. What is inside of one of the common process challenge devices? Made by 3M. Sorry, you know what? I'm just going to get my head right out of the frame. made by the 3M company. This is a very popular process challenge device. Inside the pack, there is a stack of paper that is probably about 3/4 of an inch tall, and there's a cutout in the middle. And inside the cutout, there's a biological indicator as well as a chemical indicator. On this chemical indicator, look and see that it says reject and accept. So if these strip, the chemical strip, fills up into the accept range, then this is to be accepted by the user. And it takes 4 minutes to do this. 4 minutes for it to get into the accept range. So it's going to not really be a good indicator when we're talking about a 8-minute sterilization cycle. So the challenge comes in when the steam, or in other processes when the sterilant, the one I just showed you is made for steam, when the steam is has to fight its way into the pack. It's a stack of paper that are tightly pushed together. And if the steam can get all the way into the center and change the indicators, then it has successfully shown that it can get into the tight places and all of the sterilant. So process challenge device. Next topic is tamper evident seals. So you've probably been to a store and picked up something like a gallon of milk or a bottle of Tylenol, and you've taken the cap off, and you see that there's still more to fight your way through. These are tamper evident seals on commercial products. So for sterile products that we produce, we also have to provide some tamper evident means of locking the container. So on a wrapped tray, the tape is the tamper evident seal. On a rigid container, there's usually a disposable lock of some sort. There's a picture of one on page 258 at the bottom in the middle of the top. It's a simple device. It clicks shut in the handle of the container, and it will bust if somebody opens the container. So as for the tape, if the tape on one side, let's say there's 2 strips of tape that are taping the wrap shut, if one of those pieces of tape is broken or missing, that the contents are no longer considered sterile. But I want to give you a caveat. Okay, if we're having an emergency, if the OR calls and says, I need X tray stat, and you go and get tray X and it has a broken tamper evident seal and it's tape, but the other side is intact, let the charge nurse make the call, and the charge nurse is probably going to say it's fine because the other side is intact, and it's pretty impossible to open this thing without breaking all of the tape. Now with a container, if the lock is broken, somebody could have lifted up, saw that they didn't like what was inside of it, and closed it. So that cannot be considered sterile and under any circumstances, and that would mean that they would have to emergency sterilize it. And they still might do that with the wrap tray with the piece of missing tape, but it's up to the OR in that case. So tamper evident seals also for a paper plastic pouch or a Tyvek plastic pouch. There's a tamper evident method of sealing it. Once that seal is broken, it can't be resealed without applying heat. And so it's tamper evident in that it's not sealed any longer. All right, objectives of the packaging process. Packages should allow penetration of the sterilant. They should be able to maintain the sterility of the package contents until it's opened. Of course, this depends on storage and handling and transportation conditions. If we're mishandling things, then we could inadvertently contaminate it where it might still look like it's sterile, but it's not. It should have a sealing method that is tamper evident. Okay. It should be non-toxic. Okay. It should be non-linting. It should be easy to use and cost effective. So luckily, all of these things are true of the things that are commonly used in sterile processing. Cost effective, well, it depends. Some hospitals may choose to invest in the more expensive systems for containers that have like built-in filters and built-in tamper-evident seals. If it's cost-effective for them, then it's cost-effective for them. But the majority of hospitals, all of the ones I've worked in, use the disposable tamper-evident seals and disposable filters. Okay, the FDA classifies sterilization packaging as a Class 2 medical device. So let's put the medical devices into 3 class categories based on the risk to the patient if the device should fail to perform as intended. Class 1, this is low risk or no risk. This includes things like handheld retractors and scissors, where all of the risk associated with that item is in the surgeon's hand. And then there's the Class 3, which is the highest risk, things like heart valves and pacemakers. If they should fail, then you're going to end up with a patient who is having immediate life-threatening scenario. Imagine your heart valve fails. Okay, that is the highest risk. That is Class 3, according to the FDA. Now, our sterilization packaging and everything is in the middle of that. If our sterilization package should fail to perform as intended by the manufacturer, then it does present some risk to the patient in the form of an infection potential, but it's not immediate life-threatening. So most medical devices and in packaging and container systems fall into the Class 2, some risk but not great risk category. Okay. I'm gonna pause, unpause. Okay, packaging used for steam sterilization must be capable of withstanding high temperatures. So it's a good idea, just always go with something that's been approved for the process that you're using it. Things that are approved for steam sterilization include containers that were approved for steam sterilization, wrap, like the SMS wrap, peel packs that are paper and plastic. Okay, package choices for ethylene oxide, of course, must be they must be compatible with the gas ethylene oxide, and they must be able to be aerated. When you're using an ethylene oxide process, aeration is very important because this is a toxic gas, and it, not only does it have possible negative health effects to the people who are sterilizing, but to the patient, of course, as well, and to the operative team. So it has to be aerated, sometimes for as long as 12 hours. After the cycle continues, it needs to be aerated for 12 hours to get rid of all that toxic gas. Okay, a lot of packaging choices are compatible with ethylene oxide because it's a very small molecule. It can penetrate through many different materials, and the process is compatible with a lot of materials. However, the other 2 low temperature methods that might be in place, by the way, ethylene oxide is a low temp method. So you have the steam, the high temp, the ethylene oxide that is low temp, but you also have 2 others, hydrogen peroxide and ozone. Now ozone hasn't caught on big yet, but hydrogen peroxide has almost completely replaced ethylene oxide as a low temp sterilant choice because it is less unhealthy, but also because you don't have 18-hour-long cycles with the hydrogen peroxide. You can have a cycle as short as 28 minutes, which means it's just a much better choice. So if devices are compatible with it, it's a better choice for the hospital. But not every packaging choice that you have options in your department, like paper plastic. Paper is not compatible with hydrogen peroxide or ozone because paper is made with plant material, which contains cellulose, which will absorb the sterilant. So with ozone and hydrogen peroxide, if we put paper into that process, it will cause the cycle to cancel itself, and that's a huge waste of time and money. So we have something special for those 2 processes called Tyvek. It's actually, Tyvek is a brand name, so Tyvek with an R and a circle, registered trademark, but the real name for it is called polyolefin. Polyolefin. So Moving on. Not all packaging choices are reusable. Hang on, because I didn't say that right. Some packaging choices are reusable. There's the metal containers. There is the woven fabrics. Okay, so backing up just a little bit. The SMS wrap, the blue stuff that we're going to wrap the trays in, that is single use. That ends up in the landfill. The reusable ones that we might wrap something in are called muslin, and it is similar to the scrub top. It is not very popular anymore due to the fact that it's a very high maintenance type of material. So muslin is a broad term describing a wide variety of plain weave cotton or cotton polyester fabrics that have approximately 140 threads per square inch. This. Okay. Let me tell you a story. Can I tell you a story? Yeah? Okay. So once upon a time, when I started in this field, I was working at a hospital. I won't disclose the name of it, but the supervisor was a materials management supervisor and did not know much about sterile processing. And so I'm talking about kind of like coming out of the days of the Wild West. The Wild West, as far as sterilization. There's a lot more attention paid to a lot of things in sterilization than there were when I started this in the late 90s. Hospitals are being more close, hospital sterile processing departments are being more closely scrutinized by the Joint Commission and other surveying agencies to make sure that we are doing things properly, living up to standards, et cetera, et cetera. Okay, so the story goes on. We were wrapping one thing in a muslin wrap, but it wasn't a muslin wrap that was purchased by the hospital to be a wrap. It was a patient bed sheet. And yes, this is a true story. The patient bed sheet, sometimes we would have to pull off electrodes that were stuck to the bed sheet that had formerly been stuck to patient's skin. I didn't know. I was just, when in Rome, I was doing what the Romans told me to do. So time goes on and I learn a lot of things. I'll tell you what, you probably won't be using muslin wraps, but if you are, you have to make sure that they're approved as to be wrapped for sterilization and not bed sheets. You have to make sure that they're laundered, they're delinted. You have a light table so that you can inspect these wraps for holes and other defects, even stains. If there's stains that can't be removed, those wraps should be removed from service. Okay, and we are on page 261 right now. Oh, but one more note from page 260. Canvas, the material that jeans are made out of, or sometimes denim jackets or whatever, you know what canvas is. Denim is canvas. Tents are canvas. A drop cloth that used for painting is canvas. Seems like it would be a pretty good substitute for a muslin wrap, but because the tight weave, canvas is not a good sterilization wrap. It is it's too good of a barrier. It won't let the sterilant through easily. Okay. So delinting reusable textiles on page 261. Lint is bad, we know that, but there are reusable textiles. The OR loves to have their reusable towels that they use. They go out to get laundered. They come back on a truck, a hot, sweaty truck in the middle of the summer. You bring them into your department and you're going to start folding them in a particular way. And then you're going to wrap them into sets of maybe 4 or 6 towel packs. They have to be delinted first. Trust me, the laundry service is not going to delint these towels for you. So the lint rollers that you see on page 261, that needs to be a reality in your department. If you end up working in a department where you're not redoing towels, I'd be shocked, for one, because the OR and the CVOR really love those towels. Now let's just say you're going to be delinting a lot of towels. Okay, you could be making towel packs as big as, but not bigger than, 12 inches by 12 inches by 20 inches. Now this is the largest linen pack that can exist because this is the maximum density. It'll weigh 12 pounds and it'll be 7.2 pounds per cubic foot. You probably will never be making a linen pack that big, but you will be making linen packs. And so when you make these linen packs, if you wrap them too tightly, you are restricting the, you're trapping air inside and you're not letting the steam sterilant get into all of the surfaces. There's a lot of surfaces inside of a linen. Just how many surfaces do you think there are in the weave of this shirt? Okay. Trillions of surfaces? Okay, the steam has to contact everything inside of that pack. So if you wrap it too tightly, you're restricting the steam. Steam is a really very good sterilant, but it is not magic, and it can't perform works of magic. Okay. On page 262, we're going to start talking about rigid container systems. So look at the picture on page 262. And look at the names of the various parts of the rigid container system. I want to focus on one or two right now. That gasket in the lid, the gasket in the lid is very important that that gasket is pliable, soft and pliable. Over the course of time, after going through a sterilization process over and over again, it's going to become less pliable and it's going to get a trench pressed into it from the somewhat sharp edge of the container itself. So it's locked down onto the container, put some pressure on it, it goes through the process over and over again. It's going to become useless, although you won't know it unless you give it an inspection. If you touch it and it feels somewhat pliable, good, then it's good. But if it feels like a truck tire, then that rubber has become useless. It's not forming a good seal. So the good news is these things can be replaced, the gaskets. As a matter of fact, all rigid containers need to be routine maintenance, not by a central sterile tech, but by someone who's qualified to do the work. Gaskets need to be replaced. Locking mechanisms need to be tweaked a little bit. Sometimes they don't start locking right. If you should drop one of these lids or containers on the floor and it gets a dent, it's probably going to happen on the edge that needs to be nice and straight for it to seal properly. So if you drop it on the floor, that one's a goner until they repair it. Some advantages, though, of rigid containers. Why would you have these in your department? Well, because torn wraps are your worst enemy. Torn wraps might not get noticed until the OR or the user department opens up a set and they take the wrap and they look at it and they hold it up to a light and they look at it and they see there's a hole or a tear, and then they realize that that container, the set that was in that wrap, is not sterile. So torn wraps are a bane of your existence. Wait until you get out there and see what I'm talking about. You'll understand it. Another bane of your existence is wet packs. Now, rigid containers may, because of the extra added weight of a rigid container, it may lead to wet packs happening through a sterilization mode. However, metal rigid containers dry very efficiently, so metal rigid containers can eliminate some wet packs because they dry so efficiently. So it's kind of like, I'll tell you what, plastic rigid containers are available, but they do require longer dry times, and plastic doesn't dry well at all. Some safety concerns linked to ergonomics over any rigid container is the weight of the containers. So you got to keep in mind that if you're allowed to have a 25-pound instrument set, including the container, and the container weighs 5 pounds, then the instrument set can't weigh any more than 20 pounds. So ergonomics is an issue. However, it's still the maximum weight of anything you'll ever have to lift is 25 pounds. And that's not that bad once or twice. It's only an ergonomic issue if you use poor lifting practices or just spend way too much time doing it. But that's the nature of our job. So I'll give you a hint right now. Use good lifting practices. All right. Some potential problems associated other than ergonomics are that the latching mechanisms on containers create potential problems. This is true where it says when latches and welds break, the containers cannot be used. True. Also, it says sharp edges can injure employees. I've been poked in the palm of my hands a few times by some sharp edges, let me tell you. Filter retention plates may become dislodged, and that's always very frustrating, especially when that tray's been sitting on the shelf and you go and you take it off the shelf and you notice that the filter has fallen in because the filter retention plate just gave out at some point. And now I'm going to go ahead and mark page 265, and we're going to pick up next time when we're talking more about disposable packaging materials. Thank you for joining.